Welcome, kids. This is the coordinate plane videos. It's going to be pretty short. I love this meme. It's one of my favorites. So enjoy that, and let's jump right in. Let's talk a little bit about the history behind the coordinate plane. Now, the technical name for the coordinate plane that you are used to is the Cartesian system. Cartesian, and it's named for this guy right here. Descartes, René Descartes. He was a French dude. And he lived from 1596 until 1650. And he was pretty important. Without him, we wouldn't have the distance formula. That's the formula that lets us find the distance between two ordered pairs. But there were a couple of things he did not actually do with it, with the coordinate plane. He didn't give us negative numbers on the coordinate plane. That happened with someone else. But what's kind of cool, and this happened a lot in mathematics, is at the same time René Descartes was coming up with the idea of a Cartesian system, this guy, Pierre de Fermat, was actually coming up with the same stuff. And he lived from 1601 till 1665. And what's really cool is they were both coming up with the same stuff completely independently of one another. They weren't communicating about it. They didn't tell each other about it. But they were both kind of coming up with the same stuff. And without Descartes and Fermat, we wouldn't have calculus. So that's something you can thank them for. But the person who actually sat down and made it an X and Y axis and put negatives on everything, well, that was this guy that you're familiar with because of his 3 laws of motion, Sir Isaac Newton. So he sat down and he actually had a book that he put out where he had called the horizontal axis X, the X-axis, and the vertical axis, the Y-axis, and he had negatives on both of his axes, which Descartes and Fermat didn't have at all. So that's kind of cool. Now, really, though, it's important for us to recognize that this wasn't just something that was figured out by European dudes in the 16th century, but in reality, the coordinate plane was the result of 2 millennia of practical mathematical thought. Because everything is about land ownership. If you think about the stuff you've been learning in history, or that you learned in history last year, a lot of stuff that went on was about land ownership and claiming of land. And if you think about it, map making requires a grid system. Several cultures knew this long before Descartes and Fermat and Isaac Newton. There were Greeks like Eratosthenes and Euclid from like 300 BC to 300 AD, and they had grid systems that they had created so that they could do plane geometry. Euclid was the guy who, for whom geometry you learn is named Euclidean. There were medieval Muslims in the 800s AD that actually had a pretty simple coordinate system. And in Indian culture and the Babylonian culture, there are a lot of mathematical discoveries, including stuff having to do with the coordinate plane. But because we gave the name the Cartesian coordinate system, that's why we end up with the history that we do. So it's always important to remember that history, that we read the history that's given to us, or that's written down for us by the folks who wrote it down. And there isn't a whole lot we can go back and look at for ancient Indian and Babylonian culture. Sorry, I didn't mean to move the text around for you. Let's do some vocabulary, and this video will be done. All right, you have your coordinate system. You've got your, every ordered pair has an x-coordinate and a y-coordinate. Your x-coordinate is your horizontal. Your y-coordinate is your vertical. Some old-style names for them. The abscissa was the x, and the ordinate was the y. I learned those words back when I took Algebra 1. And you have 4 quadrants that help us map out what we're looking at on the coordinate plane. So you have quadrant 1 is the positive, and it goes around counterclockwise. And remember, when we set ordered pairs on the coordinate plane, that you are counting the x-coordinate first. So let's go ahead and graph a few points. Let me list some. So let's graph these. 5, negative 1. So we start at 0, 0. Remember that 0, 0 right there? That's called the origin. And that is an important point. We start there, and we use our x-coordinate first. 5, negative 1, point. We use our x-coordinate first again. Negative 3 going to the left, negative 2 going down, point. 0, 4, it's on the y-axis. And negative 3, 0, that one's on the x-axis. So I don't think you're going to have any trouble graphing points. We will do those fun graphing projects. It's going to be the first assignment for the second quarter. So, guys, I think that's all we need for vocabulary. I'll see you in class.